So we proceed to critical flow. So we need to how to determine the critical depth of an flow on open channels. So on a critical flow, we have a maximum discharge and minimum specific energy. So usually sa mga ganitong problem, ang hinahanap is yung critical depth of flow in a open channel. So how to determine the specific energy? That is the same as the energy head. That is the velocity squared over 2g, or this is the velocity head and this is your elevation head. The depth of water in your channel. So if you can still recall the three energy heads. Velocity head, this is the equivalent of the elevation head, depth of water. And the third one supposedly is pressure head, but for open channel, we don't have a pressure head since open, exposed to atmosphere. So zero pressure. So let us equate this one to velocity. That will be equal to v squared over 2g is equal to h minus d. Or the velocity is equal to the square root of 2g times h minus d. So what is the equivalent of discharge? Discharge is equal to area times velocity. Velocity is equal to discharge divided by, what is the equivalent of area? Divided by the area. Velocity is discharge divided by v times d. So this is another term. We have the unit flow, that is the small q. Unit flow. Usually in square meters per second. So that is the same as, the equivalent of unit flow is the discharge divided by the width of the channel. So take note, this is only applicable for a rectangular section or rectangular channel. So we are to substitute this one. That is the same as discharge over area. Okay, that is the velocity is equal to the square root of 2g times h minus d. But again, we'll be having the same as unit flow divided by the d. Do you agree? So unit flow over the d. That's the same as the velocity. So unit flow over the depth is equal to the square root, or square root of 2g h minus d. Or we have the unit flow is equal to, this is the square root of 2g h minus d multiplied by d. So let us differentiate both sides of the equation in terms of the depth. So we have differential q is equal to, okay, this is the first term. We may bring out the constant, that is the square root of g. So our first term is h minus d. This is raised to 1/2, the square root sign. Derivative of the second term is 1 plus your second term, that is d. Derivative of the first term, this is derivative of you may apply derivation using power rule. So let's bring down the exponent 1/2 h minus d. Okay, your exponent minus 1. 1/2 minus 1 is negative 1/2. Derivative of your term or your base, negative d, is negative 1. So this is differential depth. So we'll be having the equivalent of differential q with respect to differential depth is not equal to, this is the square root of 2g multiplied by h minus d. This is raised to 1/2 plus, this is the same as d divided by twice of h, this is supposedly negative na siya, minus, this is h minus d raised to 1/2. So that will be the equivalent of this derivation. So sabi natin dito, maximum discharge, minimum specific gravity. If we are to maximize the unit flow, set it to 0. So maximizing unit flow will give us, okay, maximizing unit flow will give us a minimum specific energy and a critical depth. So that will be 0 equal to the square root of 2G, this will be the same as H minimum minus the critical depth raised to 1/2, okay, minus, okay, the D divided by H minimum minus critical depth raised to 1/2. Then you may, so 0 divided by the square root of 2G is the same as 0. Pwede kong i-transpose yung nasa kabit, yung negative. That is the same as D divided by, we have H minimum minus critical depth raised to 1/2 is now equal to H minimum minus critical depth raised to 1/2. So simplifying further, okay, pwede natin pagsamahin ito. Sorry, parang may nawala yung 2. So dapat may 2 dito, isa yung dito. So we have 2. So we have the same as, this is the critical depth already. Critical depth na yan. So we have the critical depth is now equal to, we have twice 1/2 plus 1/2. This is H minimum minus critical depth. So we have the same as critical depth plus twice the critical depth. This is 3 times the critical depth is equal to twice of the minimum specific energy. Or we have the relation that is yung minimum specific energy is 3/2 of the critical depth. Okay, so this is one relation of the specific energy and the critical depth. Then we substitute that one. Substitute natin ito. Okay, saan natin siya ilalagay? Dito. This equation. Or, okay, here. Dito sa unit flow. Okay, yan sa my unit flow. So we have the unit flow, we are assuming critical depth. Ito, gagawin ko lang na yung critical depth na yung D, and yung H naman is the minimum specific energy. So this is equal to the square root of 2G H minimum minus the critical depth. So this is squaring both sides is equal to 2G. This is now multiplied by H minimum is 3/2 of the critical depth. So 3/2 of the critical depth minus the critical depth. So cancel yung 2, Di pa? That is the same as 3/2. 3/2 minus 1 is 1/2. So we have, this is the unit flow squared divided by, squared lang din yan. Critical depth squared is 2G. This is multiplied by 1/2 of the critical depth. Kaya makakansel yung 1. So we having the unit flow squared divided by G is equal to critical depth squared times critical depth is the cube of the critical depth. So this is the formula for critical depth, pero applicable for rectangular channel only. So applicable lang siya for rectangular channels. So paano naman yung other channels like the triangular, trapezoidal, and so on? Okay, so what about for any shape of channel? How to determine the critical depth? So for example, we have this channel of any shape. Okay, we are to consider this a differential strip. Okay, let's say this is differential depth. We have the top base. So our differential area, differential area is the top base times the differential depth. So we have the velocity is equal to, or yung natin last kanina, specific energy is equal to B squared divided by 2G plus D, the specific energy. So all you have to do is replace B in terms of the discharge. H is velocity is discharge squared over area squared of 2G plus D. Okay. So this is the same as we have H is equal to discharge squared area raised to negative. Yes, the negative 1. That is also supposedly squared din siya. So area squared divided by 2G. So this is raised to negative 2. Divided by 2G plus the depth. So we are to perform a differentiation. This is the differential head equal to, this is, the discharge is constant squared, area is variable. So area, the area of the strip is changing. This is negative 2, or bring down exponent. This is bring down exponent, negative 2, area raised to negative 2 minus 1. Okay, this is divided by 2G, differential area. Plus, this is the same as differential depth. Dividing all terms by differential depth. So you have now dH over the differential depth equal to, we simplify this one, that is, we have Q squared. We now cancel the 2, but this one will be negative. Mag-negative na siya. We have to bring down A, that will be A, negative 2 minus 1, cube of G plus, times, this is differential area divided by the differential depth plus 1. Alright? So what is the equivalent of differential area over differential depth? So mula dito, differential area is equal to the top base times the differential depth. So we have differential area divided by the differential depth is basically equal to the top base of the channel. So we have, that is the same as B. So we substitute. So this is the same as we have dH over differential depth is now equal to negative discharge squared divided by area cube G. Equivalent of dA over differential depth is the top base plus 1. So we have the same as, okay, so this is the same now as we have to transpose ko to, we have discharge squared divided by G is equal to area cube divided by B. So this is the formula for the critical depth for any shape or any section, any open channel. So kahit anong shape ng open channel that can be solved by that equation. So this is only for rectangular. Ito naman for any section for the computation of the critical depth. All you have to do is express area and the top base in terms of the critical depth. Let's have an example for critical depth. So again, for critical flow, discharge is maximum, but the specific energy is minimum. So water is flowing at a depth of 1.5 meters in a 3 meter wide rectangular channel having ends of 0.013 and the slopes of 0.0009. Determine the critical depth. So the critical depth for the most for rectangular channel, that is, we have the unit flow squared. This is divided by the acceleration due to gravity, the critical depth cube. Unit flow is equal to the discharge divided by the base width, or that's the width of the channel. So let us determine the discharge. So discharge is equal to area times velocity. Discharge is equal to area 1 over n, hydraulic radius raised to 2 over 3, s raised to 1/2. So we have the discharge equal to area, that is equal to 3 times 1.5, okay, multiplied by 1 over roughness coefficient 0.013. Hydraulic radius is area 3 times 1.5. Wetted perimeter is 3 plus twice up 1.5, this is raised to 2 over 3. Hydraulic slope, ito yun. We have 0.0009, this is raised to 1/2. So let's determine the discharge. So it will be equal to 8.572 cubic meters per second. So double check. So 8.572 cubic meter per second. So you have the unit flow is equal to the discharge divided by the base. This is 8.572 divided by 3. So meron tayong unit flow dito. It will be equal to 2.857 meters squared per second, per square meter per second. Okay, so we have now the unit flow. We can have now the critical depth. So that is the unit flow. We have 2.857 squared divided by 9.81 is equal to the critical depth raised to 3. So let us determine the critical depth. This is equal to 0.941 meters. So that will be the critical depth of flow. So maximum at that point, maximum discharge, but minimum specific energy. So using this critical depth, you can compute for the critical velocity, or you can have the critical slope. So as long as you are using the critical depth, lahat ng values na involved, for example, the critical velocity, critical slope, lahat ng magiging critical values. Another example, critical depth, but this time non-rectangular section. So this is a trapezoidal. So water flows at the rate of 25 cubic meters per second in a trapezoidal channel having a base width of 3 meters and sides loop 4 horizontal, 3 vertical. The canal line with concrete with n equal to 0.013 determine the critical depth. So how to determine the critical depth for a non-rectangular section? That is the discharge squared divided by the acceleration due to gravity, the area of the section cube divided by the top base. So you have the top base, okay, unknown dimension, let's say B. All we have to do is express A and B in terms of the critical depth. So what will be the dimension of the top base? This is the same as 3 meters. 4 horizontal, let's say this is X. So 4 is to X, and 3 vertical is to the critical depth. So we having the equivalent of the X in terms of the critical depth is 4 over 3 of the critical depth. Okay, so 4 over 3 of the critical depth, that will be the value of X. So the value of the top base is 3 meters plus twice of X. We'll be having the top base equal to, or that is the base, lower base na 3 meters plus twice of X. So you have the lower base is now equal to, this is 3 plus twice of. Ito yun, we have 4 over 3 of the critical depth. So you have the top base is the same as 3 plus 8 over 3 of the critical depth. So it's the equivalent of the top base. So how about the area? What is the area in terms of the critical depth? So we have the area is equal to the top base plus the bottom base divided by 2 times the depth. We have the area, what is the equivalent of the top base? Ito yun. That is the same as 3 plus 8 over 3 of the critical depth plus the bottom base. That is the same as 3 divided by 2 times the critical depth. Okay? So we'll be having the area is equal to that is 3 over 2 of the critical depth plus that is the same as 3 plus 3. And we have 3 plus 3 over 2 is the same as 3 critical depth plus we have 8 over 3 divided by 2 is the same as 4 over 3 of the critical depth squared. So yun naman yung equivalent ng area. So if you are to substitute this one, this value, the values, we have the discharge, this is 25. 25 squared divided by G, we have 9.81. Equal to area, the area is equal to, we have 3 critical depth plus 4 over 3 of the critical depth squared. I think that is raised to 3. This is divided by the bottom base, we have 3 plus 8 over 3 of the critical depth. So you may use trial and error, siguro, or to compute for the critical depth. Or ship solve. We may further simplify o lang din naman. Alright, so we have the critical depth equal to 1.392 meters. So that will be the critical depth. Double check natin. Oh. 1.5 section 1.5 20